Energy efficiency for elevator solutions in high-rise buildings. I'd like to talk to you a little bit today with ThyssenKrupp in regards to how we're viewing energy efficiency. We would like to maybe talk a little bit more about environmental efficiency and challenge the organization here or the people here in the room to talk about how can we capture that going forward in regards to a guideline. Who would have thought that into the modern world we could be sitting here talking about two counterweights running in the same hoistway as one example of environmental efficiency. We all know the trends and where we're headed in regards to urbanization, globalization, demographics, and the change from going from the country into the cities. I think it was an interesting statement last night at the leadership meeting where there was a comment to say over the next 10 years we have to build a city to be able to hold 1 million people every week for the next 10 years based on what's happening to our population. So I think that frames up exactly the challenges we have in the vertical transportation industry. When we say technology is our engine, I would say it's beyond that. This is a photo of actually an SF-1000 machine. It's a permanent magnet, high-efficiency, gearless machine that's being hoisted in place at the World Trade Center project. I was very honored to have such an iconic project in our portfolio, and I happen to be have the opportunity to be the lead engineer on it, which is a bit of a once-in-a-career lifetime opportunity. So we're excited to talk about what we've done with this technology going forward. Urbanization, I already said, 1 million people city a week. So that speaks for itself. How do we handle the capacity in both horizontal and vertical transportation throughout the buildings and cities of the future? Not only do we have a change in regards to the number of units and the handling capacity, buildings are getting taller and taller. It's said that the vertical transportation industry today is the limit in regards to where building technology could actually go. So we have to arise to the occasion. Besides the fact buildings are getting taller, we also have to deal with the larger mixed use. I was in an earlier session today where they were talking about dampening dynamics of buildings. In that earlier session, they were showing the various different buildings going forward. Every one of them were based on a mixed-use approach, which puts even further and more challenging traffic handling demands on our designs. So we come to the main topic. Besides energy efficiency, I want to really talk about space efficiency. In the end, space equals energy. It's carbon footprint. It's construction costs. It's material function. All those things are all rolled up and linked to it. And with the taller the buildings, the more difficult it is for us to get the handling capacity and the amount of space available. One of the reasons why in the earlier session we were talking about dampening of a building is simply because they're getting more slender. Space is getting a premium. We can't afford the space it takes to do 1 million population city each week. So you essentially have buildings becoming cities within themselves. To deal with the space, we at ThyssenKrupp Elevator took a different approach and looked at a combination of traditional and new technology equipment. Here is the CMA Tower, which is in Saudi Arabia, where we have a combination of 17 twins, 11 double deck, and some traditional equipment as well. We'll tell you in here a few minutes just exactly why. Twin is not necessarily new. It's an old idea, but with today's technology, we made it realized. Twin originally was in 1907 around the idea, and in 1931 it was further improved. Today, it's real. We've had it in the market for a number of years. What's the advantage of twin? It's simple, one thing. Energy efficiency improvement and space efficiency improvement. Here, if you look at CMA Tower, from a footprint standpoint, we had roughly about 30% reduction in the space for the building, as well as 30% lower energy consumption with an improved handling capacity over the traditional equipment. This allows for a mixed-use building to have a longer-term future in regards to handling capacity and not dealing with under-elevated issues as the building use changes. So a lot of people say, okay, what's twin? What's beyond twin? Okay, it's 2 cars and 1 hoistway. So you're running 2 cars in the same hoistway using the same entrances, 2 individual counterweights, 2 individual machines. Typically, twin needs a double entrance floor, which today in high-rise buildings is a bit of the standard. Otherwise, you have to have a blank floor or a hidden path point. We can use twin in regards to turning on cars and turning off cars between up peak versus interfloor traffic during the day, lunch up peak, down peak, and so forth. This gives us the flexibility beyond some of the traditional systems. Characteristics, as we said, it's already 2 cars and 1 hoistway, 2 counterweights, 2 machines, 2 controllers with 1 master controller overlay. I'll talk a little bit about the importance of that when it also comes to environmental efficiency, talking about safety. Life cycle costs. When we look at elevators and we look at buildings today, we need to think about it differently. In the past, the elevator industry is very much focused on being elevator focused. We're trying to change that within ThyssenKrupp, and we're trying to look at it from more the perspective of the building, looking at the overall life cycle costs of dealing with that building and dealing with the handling capacity needed or the throughput needed of people. Energy costs of the buildings are roughly about 40%. Operation costs is about 60%. Of that 40% of the energy, the elevators are 10% of that. It was an interesting opportunity this morning. I seen a presentation that said the number 5 cost driver in a tall building is vertical transportation. And if you start considering that across life cycle costs, the space consumed by elevator systems is absolute premium. How can we else look at today's existing buildings? We also heard that buildings haven't changed that drastically since the late 60s in regards to materials and direction they've taken to solve the solutions. But there's other opportunities to modernize elevators with new technology that we also use in the new systems such as Twin. LED lighting, something as simple as that. It's 90% reduction in regards to the picture that you can save just simply by looking at different small upgrades and modernization repair kits. Going to modern controllers, regenerative drives, new highly efficient permanent magnet machines. I think there's also a presentation later in the week about one of those technologies applied. Hydraulic elevators, let's say the dinosaur of the industry to a degree, where everybody's concerned about the energy consumption. There is still opportunities. We've actually pushed and take the technology where we show in our 10 meter per second machine that we were lifting into the World Trade Center. That's a Class A VDI 4707 system. We took that same technology and applied it all the way down to a hydraulic elevator today, where in North America you still have a predominant amount of hydraulics. We can do a modernization package with an existing hydraulic, updating the system and take it to a higher classification in the VDI 4707. Also escalators, auto slowdowns, shutdowns, LED lighting, different opportunities in taking old equipment and modernizing it. Different competitors have different solutions on how to modernize the equipment, all in the focus of environmental efficiency. So let's look at the multi-cabin system. If we take and compare our today traditional system, that's also a VDI 4707 Class A, and look at the Twin system that's also Class A, even when you're going Class A to Class A, which not all companies can, but even when you do that, you're going to still achieve substantial energy consumption reduction. Again, pushing forward for environmental efficiency. LEED certification. Our buildings today are focusing on LEED. We have to, as an industry, also move along that direction and focus with it. We shouldn't be arguing amongst ourselves as an industry. We should be promoting LEED as an overall example of where we can go forward and push a guideline for this to be applied to the vertical transportation. To facilitate that even further, we've tried to challenge ourselves internally and used external resources to really focus on life cycle assessment. We actually have developed now a CTBUH tool, or a simplified LCA tool, a tool that you don't necessarily need huge amounts of time and all the experts in the world just to apply or rationalize a design. Our engineers, with using the CTBUH tool, can actually very rapidly judge if the design decisions they're making on a daily basis are positive or negative in regards to the overall life cycle assessment of the product. We've done this in cooperation with some of the industry. We've done it with external companies and external parties through universities so that we can get comparable results and get an accurate tool over the average for applying it to vertical transportation. Again, this focuses our engineers, our innovation, and even an open innovation platform across universities to push where we can further take the industry in regards to LEED, energy reduction, sustainable and safe products. Safety. We come to Twin. A lot of people had concerns for a long time in regards to, is Twin safe? Can you effectively run 2 cars in the same hoistway? We have 4 different levels of safety that I'll come to in a minute, but the first we look at in regards to nominal speed and overspeed. We're using a combination of traditional mechanical systems and state-of-the-art electrical systems. In the electrical system, I'm not going to read through all these details and bore you with that. It is after lunch, after all. I'm going to try to focus that we have 4 different levels, and it's a combination of mechanical system and electrical system. The electrical system, as I said, you have 2 traditional elevator controllers, and then you have a safety controller sitting between the 2. The safety controller is a SIL 3 rated system. I think most are going to be familiar with SIL 3 if you're familiar with the safety standards throughout the world in regards to it's one of the safest software-based safety system certification you can achieve. If you look at level 2, here we're actually monitoring the 2 different elevator cars within the controllers, watching what's happening. If you go beyond level 2 to a level 3, where the elevator controllers themselves are not responding in regards to the position proximity of the 2 cars, then the safety controller comes in over top of the elevator controllers and actually still maintains a positive safe distance, electrically overriding the system. If you were to not still succeed, then you go to a level 4, where then the electrical system responds and engages a mechanical system to restrict the cars from making contact with each other as well. I think we have roughly a couple hundred jobs out now, and we've never had a level 4 incident in all the different installations that we have. Common shaft doors. This is also something that was very concerning to the group in the beginning. We actually monitor the shaft doors independently with the 2 elevator controllers, as you would in a traditional system, but then as well the safety controller is monitoring them separately and over the top, making sure that you don't have any unsafe door operation creating a fall hazard. Test towers. We're excited today to talk to the fact that we're introducing and constructing 2 new test towers. A lot of people ask why, or why are we investing in test towers? It's not just to test the elevator equipment. It's to change the mindset, to change the cycle of what we're doing in dealing with high-rise products. We want to change and be able to come at from a building interface standpoint. And if we're really going to be high-rise experts or be experts in regards to building technology within high-rise, you have to have a high-rise building to focus and function from. So to really challenge our organization and to think differently and outside of the box from an innovation view, we're building 2 different high-rise test towers, one in Rottweil, Germany, and the other in Zhongshan, China. We'll be breaking ground on both of these towers in literally the next few weeks to, again, focus on our innovation cycle, supporting this industry in a better manner with proper vertical transportation solutions that are sustainable in regards to space, energy, LEED certification, and overall the safety of our passengers, mechanics, and of you, our riding public. On that basis, that concludes my presentation. I'll hand off to Franz Arnold, please.